Hello, everyone. I hope you can hear me well. Hi, welcome back. While I'm getting our speakers today onto the stage, drop a little message in the chat for me just to say hello and just tell me that you're there. Um, if you want, you can put in a little flag to tell me where you're based, so we can see how international everyone is. I'm just inviting our speakers to the stage now. But good morning, everyone, or GM rather. It's not morning for me. Awesome.
Hey,
Hi.
hi, how's going? GM.
Yeah, going well, thank you. I think we should be waiting for Rishabh as well.
Yeah, we should wait for Rishabh.
Aha, I have seen Rishabh. Okay, awesome. Yeah, and seeing more people come into the room as well. Welcome, everybody. Hello, NGM. Hi, guys. Awesome. Nitanshu, whereabouts are you based?
Yeah, I'm currently
Hi, Rishabh.
based out of Bangalore.
Ah,
I've
oh,
been like
awesome.
building, yeah, Bangalore, India is the epicenter of tech. Yeah.
Mm-hmm. And Rishabh, what about you?
So I also live in Bangalore, but currently I'm in my hometown for 1 week.
Oh, lovely. It's
Yeah,
nice being home and getting to see family and stuff. Yeah, GM everyone. Okay, cool. Are you guys ready to go?
yeah, no, we are ready to go.
Awesome. And while you're getting your slides up, I'll just do a quick intro. So, everyone, if you haven't seen already, today's workshop is on building dApps with account abstraction using Banana SDK. So, our workshop today is with Banana Wallet. We have Nitanshu and Rishabh, both from Banana Wallet here and ready to give a presentation. Please check out the Twitter for Banana Wallet in the chat. I've also put in the Twitter for myself and Encode, so you can keep updated. And I'll quickly post the Twitters for Nitanshu and Rishabh in as well once I grab the links. Um, Rishabh and Nitanshu, yeah. Feel free to share your slides or any material once you're ready.
Cool. So
Awesome.
let's get started. So first of all, hey everyone, my name is Rishabh Gupta, and today I'm going to be talking about Banana SDK, account abstraction, ERC 4337, smart contract wallets, and a lot of different kind of stuff for you all. We'll also going through a live tutorial to how to build a dApp with account abstraction, enable smart contract wallets like the itself of Banana SDK. So dive into it. Let's dive into it. Just a small intro about the speakers. Like I mentioned, my name is Rishabh Gupta. I'm a part of Banana SDK. Previous to this, I was working at Goldman Sachs and Economy for a small period of time. Nitanshu over here has, is also part of our team. He has worked at MathWorks earlier and Zeus Network. We both are Ethereum India, previous Ethereum India fellow, and Nitanshu is also a Polygon fellow. So that's a quick intro. And what is Banana SDK? So this is Banana SDK is a wallet infrastructure that makes Web3 easy to digest for the users. So let's talk about this wallet space in general, like what are wallets and why they are important. So wallets are basically a gateway to Web3. Any user who wants to interact with a blockchain application probably needs a wallet to interact with. And if that experience is siloed, then that is really a bad impression, because there's a high chance that a non-crypto user might not get onboarded and he might drop off. So they are an important part of the overall journey of the user. And wallets stick like emails, which are a part of Web2 world. So some of the users who we were talking to, I mean, I'll say most of the users who we are talking to have said that the first email that they are using right now till date. And same has happened with the wallets also. Most of the people who have created a wallet a long time back, they are still using their wallet right now, if it has not got hacked, obviously. But yeah, so these stick. And if the experience is something which is not us friendly or something which is not secure, then that is something which should not be the case, because eventually the user will get frustrated and move to a will move to a new thing. So what are the types of wallets that are present right there, right now? It can be seen that there are EOA wallets, which are externally owned accounts, which you might have seen the kinds of MetaMask and Coinbase. I'll be talking a lot about them in the next slide. And then there are smart contract wallets, which I'll be also talking about. So what is the problem with the likes of EOAs or the wallets right now that are present in the ecosystem? So with your account so what's basically a Ethereum address, we have to first understand. So Ethereum address comes from a private key which is stored inside your wallet. For any transactions that you want to make, let's say Alice wants to make a transaction to Bob, so she wants to send some tokens. So there is a state chain involved, and that is called a transaction. And that is happening because of a private key. A private key signs the transaction and signs this state chain, which is called a transaction. And all these transactions are bundled together to form a block, which is eventually included into the blockchain. So the private key is having a lot of power. Uh, Basically, your funds are in the blockchain is just a mapping between your public address and the amount of tokens that are present with that public address. And private key has the power to change that amount. So if your private key is compromised, all your funds are lost. And we have seen this use case. I am a victim. My wallet, before starting Banana SDK, my major motivation was that my wallet was compromised and all my funds were lost. So, and nearly all of the people that we have talked to have in some manner have compromised their MetaMask or any EOA wallet that they are using. So what is the TLDR? What's the crux of using the bad thing about, I'll say not the bad thing, but yeah, not the good thing about using an EOA. The onboarding process sucks right now. For a non-crypto users, it can take about 1 hour to get onboarded. He has to write down the seed phrase. He has to understand what a private key is. And there's a high chance that with all this friction, the user will not get onboarded into a new dApp. The recovery experience that's present out right now out there, the user has to write 12 or 24 words of a long seed phrase, and then he has to store it somewhere, which I have seen people from my team also storing it digitally initially. So this is something which the crypto degen users are also not very familiar with. I mean, uh, people write it on their phones or store images of it, which is not a good experience, and we all know that this can be hacked. So, and we have seen this, like doing all this, even if the user does all this, then his wallet is getting hacked. So why is he going through this painstaking process? Also, the cross-chain experience across the multi-chain world right now out there with so many chains popping up, it's not very good, because to move assets from chain A to chain B, the user has to go through a lot of hustle, and there are still some chains which I can also not figure out how to move the tokens to. So yeah. So incoming smart contract wallets. So how are these different, and what they can do to solve these pain points? So with smart contract wallets, first of all, what we saw over there in the first with EOAs, the private key having all the power is splitted. The funds with your smart contract wallets are not stored with your private key. They are basically stored into a smart contract which is on chain, and that contract behaves like a wallet. It's like a storage of your funds, and the owner of that smart contract is the private key that is outside off chain, basically. So you might say that, yeah, over here also the private key can get hacked, and the hacker might steal away all your funds away. But the good thing about here is it's a smart contract, which is basically a piece of code. So you can add another extra functionality to it, like the likes of two-factor authentication, which Banana SDK is offering. You can have multi-sigs, which Gnosis Safe you might have heard of is a popular example, and many more security features. So all these functionalities are just to prevent your contract to prevent your funds from getting stolen. So a popular analogy that's going on right now is like externally owned accounts are like previous initial phones that Nokia provided with just a with just a keypad, and the smart contract wallets are like a smartphone which can be customized by the user. So these are some advantages of the smart contract wallets out there. I mean, the list is so long that I cannot even list all of them. But yeah, some of them which feel important to me are providing two-factor authentication to a transaction, having a recovery mechanism which is Web2 friendly, which is provided by Banana SDK. You can have multiple signers also provided by Banana SDK, and many more to come. So what is now, so we have covered the topic of smart contract wallets and EOAs. So what is now account abstraction and how is it related to the smart contract wallet world? So account abstraction is basically a proposal which is seeking to improve the user interactions with Ethereum. And what it means is the role of account abstraction is basically to use smart contract wallets and make the user experience really better for the Ethereum or the blockchain users in general. In reality, smart Ethereum consensus level at Ethereum consensus level, we cannot have account abstraction based smart contract wallets because earlier it was not ready and people were I mean, I have read the story and it was said that they wanted to launch Ethereum. They were in the pressure to launch Ethereum, and there were many talks going on about smart contract wallets to get launched, but they were not ready at that time, so they were not able to. But layers like L2s like Starknet or ZK Sync have smart contract wallets inbuilt. So, but it cannot be done right now in Ethereum because they will involve a lot of consensus level changes. And so that's why ERC 4337 comes into play, and which is an ERC, which is just like ERC20 token. So this is not something that will make changes in the inherent protocol. It is just something which all the users or the developers can adopt to. So without making any consensus level changes. So it can be fairly adopted by everyone. So ERC 4337 states this only, that when the user wants to make a transaction, the user's transaction is picked up by an entity called a bundler. So what a bundler is, if you ask, if you have interacted with the blockchain, then you must have know that you need a node service, somebody like from the likes of Alchemy or Infura. And if you are not interacted, just let me just tell you that these are node servers which are running in the backend, and what their purpose is to, when you are posting a transaction to the blockchain, they pick up the transaction from you and post it into the mempool. So what a mempool is, basically, it's you can think of it as a swimming pool with a lot of transactions. It's a public swimming pool, and all the transactions are dumped into it. And whenever the block builder wants to make build a block, then he picks up the transactions, validates them, and builds the block. So the bundler does this only in ERC 4337. It picks up the transaction from the user, and then it posts it to the entry point contract, which makes all the valid checks that the transaction is valid or not. The smart contract will be able to fund the transaction or not, and the state changes are not faulty. So all these checks are made by the entry point contract, which is a central contract deployed on every blockchain, that will be deployed on every blockchain. And all these things the user doesn't need to worry about, because all these things are provided by the Ethereum Foundation, and people are working. It's heavily being researched upon right now, and a lot of work is taking place in this direction. So the entry point contract basically is like a manager, and it handles all these things. The bundler posts the transaction to the entry point contract. It makes all the valid checks, and then the transaction is executed. So here's a summary of what ERC 4337 looks like, and how is Banana SDK using all this, providing a best experience to the user, to the applications to get onboarded. So Banana SDK, as I have already mentioned, that it solves the user onboarding problem, provides you with an in-app account abstraction based smart contract wallet infrastructure. So what it means is it's not a standalone wallet. Applications can integrate to have Banana SDK, Banana Wallet to onboard new users, which can use Banana Wallet. And the major functionalities that Banana SDK provides are basically creating a wallet or signing transactions from your wallet through your biometrics, basically your touch ID or your face ID. And I mean, this is much and this is a really cool feature which I'll just show you after this presentation. Second feature which we are working is basically zero knowledge based two-factor authentication. As I mentioned earlier, which adds a second layer of security for your transactions. The third feature is having an easy Web2 based recovery mechanism. We are using multi-party computation to achieve this. And yeah, so this is a high level overview of what all the features that we are providing right now. But in this hackathon, we'll be only providing the hackers with the feature of Touch ID authentication. So yeah. So for the working of the Touch ID wallet creation and transaction authentication, let me just give you a brief overview how it's working. And you don't need to, the developer doesn't need to worry about anything for with the integration. Like for having the whole account abstraction infrastructure ready, we will be providing everything. So what the user in this, this looks complicated, but I'll break it down a little bit. And what the user does is basically whenever he comes to the application, he or she provides their touch ID or face ID while creating a wallet. As soon as they do so, a private key is being deployed, is being generated inside the user's hardware, and it's stored inside the secure enclave of the hardware, which is basically a part of the hardware which does not interact with any application, and it has its own operating system or and RAM and everything. So it's super safe to store the private key over there, and it can never get leaked. So that's what we do. And after this private key is generated, smart contract wallets are deployed across multiple chains so that we can have cross-chain functionality. And after those wallets are deployed, the user is ready to go. He doesn't need to go anywhere. The wallet is deployed on under 1 minute, and you'll see all this in action. I mean, in the demo that Nitanshu will be taking you through. So yeah, this is a high level overview. Everything is managed by a SDK, and the user will get a really nice UX while interacting with the blockchain. So this is the architecture of our zero knowledge based two-factor authentication. I'll as mentioned, this is not provided for the hackathon purposes, but yeah, just a high level overview is what we are doing is we are using Merkle inclusions proofs, and which what it does is whenever user enters an OTP in the future for executing a transaction, that OTP is converted into a zero knowledge proof, and that is transferred with the smart contract with the transaction to the smart contract wallet. After that proof is verified, we are making the transaction. So that acts as a second layer of security to the user. So yeah, I think I'm done with my presentation. And if there are any questions, can we take questions right now, or should we wait till the end?
Absolutely. I guess it's up to everyone in the chat, but I've definitely had some questions pouring in. I think Nitanshu has tried to answer them when they have come in. Just a little comment to those in the audience as well. Feel free to post your questions in the questions tab so they don't get lost in the chat as well. That's also an option. I think general questions are on what does Banana SDK work with at the moment, what is supported with Banana SDK, what chains are supported, and kind of what wallets do you work with as well.
Yeah, so to answer, I think there are multiple questions to this, and to answer the chain question. So for the purpose of this hackathon, we are live on Gnosis Chiado network and the Gnosis main chain, and we are also live on multiple blockchains like Polygon and Ethereum's Borelli network and all these Arbitrum and Optimism. So if the user wants to experiment over there, he can do that also. And to answer the second question, which I think was like what wallets are supported. So Banana SDK is itself providing a wallet to the user. So the user doesn't need to have another wallet. we only provide the gateway to Web3, and that is, I think, yeah, that answers the question.
Yeah, that's fantastic. Thank you so much. Yeah, I know, Nitanshu, you answered this in the chat already, but great to have it on the recording as well for anyone watching this video later on at home. Okay, yeah, I think that's all the questions so far. Feel free to carry on.
Yeah, no, Nitanshu, you can take
Sure,
over.
sure, sure. I think like Rishabh that covers most of the theoretical part and definitely gauge some interest from the audiences. But we are developers. We believe in coding actually. So let's start actually implementing account abstraction based smart contract wallet using Banana SDK. So for the purpose of this particular hackathon, Gnosis Encode hackathon, we had created this tutorial. It's a really succinct tutorial which follows the integration of Banana Wallet SDK. And we would be following this particular tutorial. And if some hackers want to try their hands on during this particular session itself, they can do so, and we would be happy to help them building on top of Banana Wallet SDK. So yeah, let's get started. So first of all, let's just create a sample React app, Banana SDK demo. I had already created a sample React app. Let me just go into it. Yeah. So my app is already on. It's just a normal React app. And we will be kind of like integrating our wallet SDK into this particular application. And we will be building a sample application to kind of like make transactions, get chain IDs, do some dApp level stuff basically. Yeah. So let's just install our SDK. For installing our SDK, you just need to, you can use any package manager, you can use NPM, you can use yarn. For this tutorial, let's just use it with NPM. For installing our SDK, you just need to install using NPM install Banana Wallet Rishabh/Banana Wallet SDK. Rishabh is the parent company and Banana Wallet is actually the name of product. So that's the whole nomenclature idea over here. Let's just wait for a minute to get it installed. Meanwhile, we can just kind of like remove some boilerplate stuff from app.js. Yeah. Demo. Okay, great. And like we might face some Webpack polyfill issues which occurs during because of Webpack version 5. So let's just install this boilerplate node polyfill module so that we can basically escape from those clunky issues. Let's just override those node polyfill changes by creating an config override. Yeah, and just change the start script to React app rewired specifically. So yeah, we are done with this with setting up the development environment for integrating Banana Wallet SDK into a local dApp. Let's just start building it. So for this purpose of tutorial, what we would be doing is we would be calling the stake function of this simple sample contract, and this stake function will going to change the state variable of the smart contract, which is the staked amount. And in changing state variable of a smart contract for sure involves say transaction. So we'll be making transaction using the smart contract wallet deployed using Banana Wallet SDK. And for the reference for this particular tutorial purpose, I had already deployed this particular contract on this address. So if you want to start using this contract as a sample purpose, we can just use this particular address, and this contract is available on chia.testnet. We can start building it. The front end we would be building in this particular tutorial would look like this. Basically, it will contain several buttons which will dictate the functionalities wallet has to offer. Like basically, we can make transaction, we can sign messages using our wallet, get the chain ID, get some information about the current network, connect wallet, and create wallet on all those stuff. Yeah. So let's start integrating the Banana wallet. So first we need to get the Banana and chains modules from our package. Banana modules is kind of like a wrapper module which has all the facilitative methods you would be requiring for creating wallet, connecting wallet, and doing some other stuff. And chains is basically a module which basically exposes all the different chains we are currently supporting right now. Yeah, we are successfully imported. And let's just let's just import some React level stuff. Let's just import use effect state and hook and use state hook. And let's just import ethers as well. We would be using ethers for some encoding purposes later on for building transactions. And let's just get the API for the sample smart contract I had just shown you right now. So that using that particular API, we can encode the stake function for making transactions. So let me just grab the API super quick. So we had already made this tutorial public. If you guys want, we would be dropping the link to this tutorial for sure later in the chat itself, and you can access the tutorial from this particular link. So let me just grab the sample API for the contract we have been making transaction for. Let me just put it here, sample API.js. Yeah. So let's just import the sample API for this contract we would be making transaction. Yeah, done. And let's just initialize some states we would be using in our app. These are just kind of like a utility state. Wallet address would gonna hold the address of wallet. Banana SDK instance will going to hold the instance of the SDK. Yeah. Now let's create an instance of Banana using the Banana module. For creating instance, you don't need to do much. You just need to initialize an object for this particular Banana module. Yeah. So let's just create an object for Banana module. We had created a function to get the Banana SDK instance. And let's just name it Banana instance as of now with new Banana. And for the purpose of the tutorial, the change we are following is tr.testnet. So you can just use tr.testnet. And let's just store this particular Banana instance for our purposes. And in use effect, let's just call this Banana, get Banana instance, so that whenever your app reloads, your app would have a fresh instance of Banana. Yeah, this is done. And now the main stuff comes in. So first, what we would be doing, we would be creating wallet. So for creating wallet, what you need to do is you just need to call out the create wallet method, which our Banana SDK instance offers. So let's just copy this particular piece of code. And let me explain you what it does. So in create wallet, we had exposed the create wallet method from the Banana SDK instance. So user just need to call this create wallet, and whenever this particular method has been invoked, it internally prompts user for entering a username. And a username is taken basically so that later on user can access his wallet with that particular username itself. But kind of like help us making the UX little bit more friendlier at the user side. And once the create wallet method succeeded, it returns the instance of a wallet. And from that instance of a wallet, you can just query for its address using the get address method, which is kind of like a standard thing. And once the address has been retrieved, you can just display it and you can do stuff in whatever manner you require. So once you had created a wallet, we kind of like saving some cookie data, some kind of like a wallet metadata to your browser, so that later on you can directly call out connect while using connect wallet. Basically, you can use the get wallet name method, which has been offered by our Banana SDK instance to to check does the wallet name exist in the cookie data of your browser, so that the devs at their end would be aware about whether the user has been already deployed wallet or not. So like we first fetch the wallet name from the user's local storage, browser's local storage. And if we found the wallet name, we will directly call the connect wallet with the wallet name. And it will internally do something and create a wallet instance with the wallet which user have previously deployed. And similarly, once we get the wallet instance, we can fetch the address of the wallet using the get address method offered by wallet instance. Similarly, to get connect wallet, we have like the short methods, kind of like standard methods to get the chain ID. So for getting the chain ID, what you need to do is you just need to, on your wallet instance, you just need to call get signer. It's kind of like a standard flow to get the chain ID. And on signer, once you call the chain ID, you will get the current chain ID which your wallet is using. So similarly, let's just push it down. And once you are done with the chain ID, you can for sure call for the network information you are currently working on using the get network method provided by the provider. So once you had got your instance of wallet, you can call the get provider method to get the custom ERC-437 based provider which our account abstracted Banana SDK wallet used. And using that particular provider, you can kind of like get the network information of what the current network you are actually working on. And once you are done with the get network, the most important thing is like making transactions using wallet. And it kind of like is straightforward. Once you get the instance of a wallet from your connect wallet and create wallet method, you extract out the signer from it. And using the signer, you just call the send transaction method. And in that send transaction method, you just need to pass out the transaction information of what the actual transaction you want to make. So like suppose in my sample contract, what I wanted to make is I want to call the stake function of it. So for calling the stake function, what I am currently doing is using the ethers utility, I am just passing the API corresponding to the sample contract and encoding the data for the stake function call. And once the data and value and using this gas limit to value data, I'm just constructing a transaction, which is basically gonna change the state of sample contract. And once the transaction has been constructed, I just need to pass the transaction into the send transaction method, which has been exposed by signer. And once the transaction completes, it returns the transaction receipt object as we do in normal EOAs. And similarly, we have sign message method. Sign message is again the normal kind of like a standard utility method provided by wallets. We had kind of like abstracted all the complexities of the Banana SDK kind of and made the interface similar to the existing EOS so that at the developers and it's pretty straightforward to get used to it and start building on top of it. So in the sign message method, we are basically extracting the signer from the wallet instance. And once the signer has been extracted, we are basically expose a method called sign banana message. And once this particular method has been called, we are passing the sample message which we need to sign. So for the purpose of this tutorial, let's just sign a sample message called hello world. So I just pass the sample message to sign banana message. And let's just for the front end purpose, I had already added a boilerplate code. So I won't be writing that particular code. So let's just copy this. And we would be having our front end ready. This front end does nothing. It just exposes several buttons, which on click basically has some on click callbacks and create and basically invoke the corresponding methods. And let me just also copy the CSS so that it would be kind of like little beautiful at your eyes. So here's the CSS available. It's again publicly available. So if you want, you can after this particular workshop, you can just go and have a look on. So yeah, we are done with creating a sample application, sample demo application using the Banana SDK, and now just launch it. So the server is pinned up at localhost 300. Yeah. So we have our Banana SDK demo is pinned up. Let me just clear out the cookie information so that I can have a fresh start and create wallet from the start itself. So first, what the user has to do, like currently I don't have any wallet right now, any in-depth wallet with particular demo. So let's just click on create wallet. So once I clicked on create wallet, it asks me for a username. So let's just write a random username right now. I just provided a random username, just literally a bunch of crap. So I'll just click on connect wallet. So once this process has been done, it asks me for creating passkeys at my device end, and it also asks me to provide the touch ID. And based on the touch ID I provide, it will kind of like generate a public private key pair, and private key would gonna reside into the internal storage of my hardware, which can't be exposed, and we would be using that particular private key to sort of like link the wallet to the user. So let me just use the password, or I could have used my touch ID as well. So it's kind of loading. It's basically working on calculating the public keys and deploying the smart contract wallet. So yeah, so we got the address of our smart contract wallet, and currently, if we're gonna see at Chiado Explorer, yeah. So currently, I kind of copied the wrong thing. Let me just copy the correct thing. So if you would see, there won't be any contract right now on this particular address, as this particular address is a counterfactual address. And once I kind of like gonna make my first transaction, then only the contract would be deployed alongside. So basically, using ERC-437 account abstraction, what actually happens is the contract itself pays the funds for the deployment. So I need to kind of like fund this particular address with some XI. So let me just fund this particular address with some XI I'm having right now. So let me fund it with 0.1 XI. And a part of 0.1 XI would be used for the deployment of its own contract while making the transaction. So while this particular transaction is happening, we can for sure like use the other functionalities, like for getting the chain ID. We had exposed the get chain ID method on the signer, which kind of like returns the chain ID. For getting the network information, we basically we have ERC-437 custom network with the particular chain ID of TI to testnet. Let's see, like there's our transaction comes. Yeah. So now we had funded our wallet, our smart contract wallet with 0.1 XI. And now let's make a transaction to the sample contract. Yeah, so it asked me for the private key residing in my browser for access. And for making a transaction, I need to kind of like sign this particular transaction with my private key. So it's asking me for my fingerprint information, so that once I give this fingerprint, it's basically pass all the transaction to my hardware. Hardware prompts for fingerprints, and once I provide the fingerprints, it basically signs the transaction with the private keys which has been generated with my fingerprint. And eventually, once the transaction has been completed, it's kind of like broadcast this transaction to the network. So yeah. So as you can see, like previously we had 0.1 XI, now we have 0.97 XI, and previously we didn't have any contract code deployed, and right now, with the first transaction which we had made, we had also deployed our smart contract wallet. Yeah, so like this was the transaction which we had made. We had just basically transferred 0.4 times 0.1 XI to this particular address, and this was our sample contract address which we had previously deployed, which is available already in that particular tutorial. So similarly, to making transaction, we can sign message as well. For signing message as well, you just need to provide your fingerprints. I'd already hardcoded the message at the front end level, which is this hello world message. And after signing the hello world message, we got two things: the message signed and the signature. So why we got two things? Like we usually receive only one thing, right? Only signature after signing a message. We got two things because like once this for signing this particular message, what we are using R1 based signature. And at the hardware level, when I'm basically prompting the hardware for signing this particular message, the hardware kind of like adds its own entropy to this particular message and signs that particular message with some entropy. So that's why we are also providing developer with the message sign, the actual message which has been signed, so that developer can use the verify signature method along with this message, along with the actual message sign and the signature to kind of like actually verifies the user. So yeah, like this was the demo application in which we had integrated Banana Wallet SDK and created our first smart contract wallet, which has kind of like a which has an inbuilt signing facility using the Touch ID or the device passcode. So I would be happy to take up questions now.
Awesome. I think Rishabh has been answering a few in the chat as well. I can see one that hasn't been answered yet in the questions tab from Ayasu, saying, can ERC 4337 work as it is on Starknet or other consensus level AA supporting chains?
Yeah, maybe I can take that. This question is not that much clear to me, but yeah, if it is that ERC 4337 can work on Starknet, then the question ERC 4337 enables you to use smart contract wallets. But in Starknet, you are already having smart contract wallets, so I don't think it's required over there. So the major purpose of using this ERC is already solved over there.
Awesome. Thank you. Any other questions? Feel free to type it in the chat. I can see that Iyasu is typing a response as well at the moment. Great. Here we go. What pass is different? Iyasu asks.
What exactly, I mean, do you mean, is it the bundler? For the Starknet issue, if you're asking about the Starknet, then I don't think Starknet is using ERC 4337 to enable account abstraction. And those are basically L2 rollups, L2 ZK rollups. And so the whole architecture over there is different, I think, when compared to the EVM architecture for using smart contract wallets.
And
I
adding
mean,
to that,
nothing,
like
yeah.
it should not be the bundler, like because like kind of bundler introduce an alternate mempool kind of entity in the whole ERC 437 network, but the same thing doesn't replicate to the Starknet.
Yeah, cool. Yes, it says thanks, if you couldn't see. Great. Everyone else, feel free to ask any questions, any more questions that you have in the chat, or how else is best to contact you guys if our hackers have any other questions in the future.
I'll drop my Telegram. I mean, my
We
Telegram
had
and
we
Instagram
have our
handle
own
as well.
Discord community as well.
Yeah,
Sure.
Amazing.
yeah, yeah. So we will
Cool.
drop our personal handles also, and you can contact to our Discord community or Telegram community. Anywhere you want to find us, you can just message us. We'll be replying you.
That's perfect. Cool. And I think we have a little bit of time left.
Yeah, I'll
I just
just
wanted to. Oh, yeah.
Yeah, just one last thing is left. I just wanted to go through the hackathon prizes that
That's what I was going to ask as well.
yeah, yeah. So yeah, we are offering three prizes in this hackathon, and the first one is most innovative use case, which basically means that whatever you have learned so far about Banana SDK or from our docs, you can build on top of that. You can help us. You can contact our developers, Nitanshu or me, anyone from our team, to brainstorm ideas or whatever you think is best. What's a innovative use case for Banana SDK should be according to you. The second and the third are basically having an existing dApp which is present out there and which can basically use our SDK to enhance their user experience or user retainability or anything that you feel is important to that app, and Banana SDK can solve it. And just to mention, Nitanshu has covered a native integration of Banana SDK over here, which but you can also have, we are also providing rainbow hooks, rainbow and wagmi hooks. So if anyone wants to have rainbow integrated with their application, with the power of having all the other wallets also, so we have integrated with rainbow, and it's pretty, I mean, it's much more simple, I'll say, to have rainbow also with Banana SDK. So it's very simple. You can go through our docs. There is a full tutorial for this, and a video tutorial is also out there. So plenty of material out there. Also, you can contact us anytime. Yeah, so this is basically it from our end.
Cool. Amazing. While that's still up there, then I have a quick question as well. Why the irregular prize amounts? I find it
Sorry.
very intriguing. The prize amounts that you've offered all end in a 0.7. Is there any
Yeah,
specific
yeah.
reasons?
It's because of the ERC 4337.
Oh,
The
I
account of,
see.
yeah, so that's why.
That
Yeah.
makes so much sense. I love
Yeah.
it. Very memorable.
Yeah. Thank you.
Awesome. Well, I think that's perfectly taken us to time. I guess I'll just say a few things to wrap up. I'm just going to minimize this screen, but the QR code is still there in case you guys want to scan it. You should be able to scan it. Or I'm sure we can pop that in our own the Hackathon Discord channel and stuff. I will. So I'm going to quickly go through a couple of housekeeping stuff. To anyone, if you haven't registered for the hackathon yet, please do so in this following link, and also access the Hacker Pack here. Another thing is, now we're starting to get into the second half of this hackathon. I would love to have a few more one-to-one calls with you guys, and see what projects you're building and see how everything's going and keep up to date. So everyone in the audience who is planning to hack, please book a little one-to-one call with me using my Calendly link. I've just posted it there. And you can also find it in some of the emails that I've sent out. And lastly, regarding any of the documents or the slides from this presentation today, I will be reaching out to Rishabh and Nitanshu to make sure I get those for you, and I will put all of those resources in our Discord. And of course, we'll link as well to ways to contact our wonderful speakers today. Cool. I think that's everything from me. Would you two like to say any last words?
From my end, it's basically like hackathons are the best ways to learn new things, and I have learned everything in Web3 and in apart from Web3 also in from hackathon. So yeah, I think I'll say that all the hackers to all the hackers, like, yeah, bring us the best that you have.
Yeah, that's awesome. Cool. Well, on that note, then, the chat will stay open as usual, as Nitanshu's just put in a lot of awesome resources in there. But I will close the stage now. So thank you everyone so much for coming and being engaged in the chat. And thank you again, Nitanshu and Rishabh, for speaking today. It was really awesome. Cool.
Thank you. Thank you so
Right.
much.
See you guys.
Thank you, everyone.
Thank you, guys.
Bye.